So alcohols consists of two parts. One is alkyl or R-alkyl, and then second group is hydroxyl group. So for example, ethanol and propane have comparable molecular masses, but their boiling points differ wide. So the hydrogen bond between hydrogen and the electronegative atom has been shown with the dotted lines. That is what hydrogen bonding means. The function of concentrated sulfuric acid is to act as protonating agent as well as a dehydrating agent. Hello dear students, I am Roja, your chemistry lecturer from Vidhyaashram PU College, the Temple of Excellence, Mysuru. So today we are going to continue the chapter Alcohols, Phenols and Ether. So in the previous session, we have studied about alcohols, then classification of alcohols, then nomenclature, then structure of alcoholic functional group, then methods of preparation. So in this session, we are going to study about physical properties and chemical properties of alcohols. So let us start with physical properties of alcohols. So alcohols consists of two parts. One is alkyl or R-alkyl, and then second group is hydroxyl group. The properties of alcohols are due to the OH group that is present in the compound. So alkyl and aryl groups modify these properties, that is boiling points and solubility. So how are they going to modify? Let us see one by one. So alcohols are basically colorless liquids. Lower members of alcohols are soluble in water due to the formation of hydrogen bond, but the solubility of alcohols decreases with increase in the size of alkyl groups. So here is a representation of alkyl groups and hydroxyl groups attached to each other, and therefore making it an alcohol group. So here we can see R represents alkyl or aryl groups. So if the size of the alkyl or aryl groups increases, then it decreases the solubility in water. So the boiling points of alcohols are much higher than the corresponding alkanes due to hydrogen bonding. So here is the hydrogen bonding between the electronegative atom and the hydrogen atom. So but in isomeric alcohols, boiling point decreases. Then hence alcohols will have higher boiling points than the corresponding other classes of compounds and haloalkanes and haloarenes of comparable molecular masses. So for example, ethanol and propane have comparable molecular masses, but their boiling points differ wide. The boiling point of methoxymethane is intermediate of the following two boiling points. So here is an example, ethanol and propane. Intermediate product of these two, that is methoxymethane, will have intermediate of these two boiling points. So ethanol has got 351 Kelvin and propane has got 231 Kelvin. So intermediate of that is a boiling point of methoxymethane, that is 248 Kelvin. Then how about solubility? The solubility of alcohols in water is due to their ability to form hydrogen bonds with water molecules. So solubility decreases with increase in the size of hydrophobic group. So that is represented by R. So the hydrogen bond between hydrogen and the electronegative atom has been shown with the dotted lines. That is what hydrogen bonding means. So then the solubility decreases with increase in the size of hydrophobic group. Next is chemical properties of alcohols. So chemical properties of alcohols are mainly due to the presence of hydroxyl functional group again, and the reactions of OH groups in alcohols may be divided into two types, that is reaction involving cleavage of oxygen-hydrogen bond, and the second one is reaction involving the cleavage of carbon-oxygen bond. So let us study one by one. What is this reaction cleavage of hydrogen and oxygen bond and then carbon and oxygen bond? So in that, first one is reactions involving cleavage of OH bond. So that is acidity of alcohols, wherein reaction of metal gives the acidity of the alcohols. So alcohols react with highly electronegative alkali metals such as sodium, potassium, aluminium, etc. to yield corresponding alkoxide with the liberation of hydrogen. So here is an alcohol group wherein suitable metal is going to react with each other, therefore forming it a sodium alkoxide. Along with that, hydrogen is liberated. Here is one more example, that is tert-butyl alcohol. So this alcoholic group wherein hydrogen is being liberated and then metal is being replaced, therefore forming it aluminium tert butoxide, and hydrogen is going to liberate. Next, the above reactions show that alcohols are acidic in nature. In fact, alcohols are bronzed acids, which is they donate proton to a base. So base is represented by B along with two dots. Two dots represents lone pair of electrons. So alcohol groups consist of oxygen, wherein it can donate electrons to the strong base. So here is a general equation: base plus alcohol, which acts as an acid, can form conjugate acid, that is BH, along with that alkoxide ion, which is known as conjugate base. Next is effect of substituents on acidity of alcohols. What happens if the substituents are there in the alcohol groups? So the acidic nature of alcohols is due to the polar OH bond. An electron donating alkyl group increases the electron density on oxygen and then decreases the polarity of OH bond, and also decreases the stability of alkoxide due to plus I effect. So this decreases the acidic strength of the alcohols, and therefore the acidic strength of primary, secondary and tertiary alcohols is in the following order. That is, primary alcohol is greater than the secondary alcohol, which is again greater than tertiary alcohol. Alcohol acts as bronzed bases as well along with bronzed acids. So it is due to the presence of unshared electron pairs over oxygen atom. That is because of electron donating group will have more of electrons towards the oxygen atom, which makes the alcohols as proton acceptors. Then alcohols are weaker acids than water. So why is that called weaker acids? Let us know the reason. So in alcohols, due to the electron donating nature of alkyl group, the stability of alkoxide decreases. Here is a general equation wherein ethyl alcohol dissociates to give alkoxide plus proton. So that is going to decrease the stability. The formation of alkoxide will decrease the stability of the alcohol. But in the case of water, the hydroxyl ion formed by its ionization is more stable than the alkoxide ion due to the absence of electron donating group. So in the water, there is no electron donating group. So therefore, it is responsible, that is, hydroxyl ion is responsible for the stability of the water molecule. Hence, alcohols are weaker acid than water. So next is reaction involving cleavage of OH bond. In that, we shall study esterification of alcohols. So esters are produced when alcohols are heated with carboxylic acid in the presence of an acid catalyst, and the process is known as esterification. So the catalyst is usually concentrated sulfuric acid or dry HCl. The function of concentrated sulfuric acid is to act as protonating agent as well as a dehydrating agent. So here is a general equation, represents carboxylic acid then alcohol. So this proton is donated by either concentrated sulfuric acid or HCl, therefore forming an ester. This H2O group is eliminated from this carboxylic acid and then alcohol, grouping it together to make an ester. So the general formula of ester is RC double bond O, OR dash, and R and R dash can be either alkyl or aryl. Next, examples are given based on the esterification process. So acetic acid plus methyl alcohol, wherein if water molecule is eliminated, then we can produce methyl acetate. Second example, acetic acid plus ethyl alcohol. So the alkyl group is increased further, making it ethyl acetate, then water. Then we have aromatic compound, that is benzoic acid plus alcohol, therefore producing ethyl benzoate plus water molecules. So next, esters can also be obtained by treating alcohols with acid chlorides or acid anhydrides. The reaction with acid chloride is carried out in the presence of a pyridine base so as to neutralize HCl, which is formed during the reaction, and the introduction of acetyl group in alcohols is known as acetylation. So acetyl group general formula is CH3CO. Now general equation represents, that is alcohol ROH plus acid chloride, that is R dash COCl. In the presence of pyridine, it is going to form ester, then HCl. If you consider the example, that is methyl alcohol plus acetyl chloride. So here hydrogen and chlorine are going to form hydrochloric acid, forming a methyl acetate along with that. Next example, that is ethyl alcohol then acetyl chloride. It gives ethyl acetate along with HCl. Then next is oxidation of primary alcohols, wherein oxidation of primary alcohols involves, it is easy to oxidize to form first an aldehyde and then a carboxylic acid. So in the presence of strong oxidizing agents like acidified potassium permanganate solution, or we can use acidified potassium dichromate solution. So general equation is RCH2OH alcohol. On oxidation, it gives aldehyde, and on further oxidation, it would give carboxylic acid. So here we have another equation. In the presence of potassium dichromate, that is RCH2OH, gives out aldehyde. Next, oxidation of primary alcohols to aldehyde stage can be stopped by mild oxidizing agents such as pyridinium chlorochromate, which is called as PCC. It's a complex of chromium trioxide with pyridine and HCl. So the complex is known as C5H5NH whole to the power plus ClCrO3 minus. So by using this reagent, aldehydes can be isolated in this reactions. Directly we can produce carboxylic acid. So here is an equation, that is but2-ene-1-ol plus PCC on oxidation gives crotonaldehyde plus water. Next is oxidation of secondary alcohols. So secondary alcohols are oxidized to ketones by chromic anhydride CrO3. So general equation is secondary alcohol using chromic anhydride, ketones are produced. So if it is isopropyl alcohol undergoing oxidation in the presence of chromic anhydride, able to produce acetone. Next, tertiary alcohols do not undergo oxidation reaction easily. Under drastic conditions, strong oxidizing agents like KMNO4, that is potassium permanganate solution, at elevated temperatures, cleavage of CC bonds takes place and a mixture of carboxylic acid containing less number of carbon atoms is formed. So the reaction depicts the actual given description, that is tertiary alcohol on oxidation, that too with the drastic condition and elevated temperature, it is going to give ketone, and on further oxidation it is going to produce carboxylic acid. So let us see with an example, that is tertiary butyl alcohol, and on oxidation along with the drastic condition or in the presence of alkaline KMNO4, it is going to produce acetone, and on further oxidation it is going to give acetic acid, a group of carboxylic acid. So that was about today's session. So in the next session, we are going to study about reactions involving cleavage of carbon-oxygen bond in alcohols and then some commercially important alcohols. So thank you.